What do you
This,
want me to do when I introduce myself?
now we're in demo with my boy. Introduce yourself.
Hello, my name's Alan.
All right. Okay. So, what the whole program does is essentially I will draw a rectangle from the top left corner of my map to the bottom right, and
Mm-hmm.
my AI will predict where you are based on
Mm-hmm.
like the vision on my map. So it'll tell me
Okay.
top, mid, or bot. Okay.
Okay.
All right. All right. I'll run the program then. So if I press main.py, okay, there. Now it should be running. So I want to track graves. So I'll type that in. Boom. Now what you'll see is that this screen pops up. What I'm going to do now is draw a bounding rectangle. So boom, right there. And something should pop up. There we go. So now that's showing. I'm going to drag that out. And what we have left is a little window here of, oh, boom, okay. That's perfect. Now that it's running, we see in this other little live feed where my opponent actually is, aka Alan. So right now, he's showing that it's top, which is perfect. That's what we want. Now, Alan, can you walk down to mid, please?
Of course.
And please show your vision on the creeps, or else I won't be able to obviously
Mm-hmm.
detect you. Boom. So as you see, the white text on the left here, it instantly changes to mid. Now, if Alan comes down to bot lane with me right now, and Alan, if you could just walk to the bush where people gang from, perfect. Now it says bot. Okay, perfect, perfect. In this left place right here on the map, you can see that it says bot. And essentially, if you look at the map, you'll see that there are dots throughout the entire plane. You'll see that there are dots littered from mid, top, and bot. What it's doing right now is it's calculating Alan's current position, aka Graves, to those dots, and it's telling me which one it's closest to. If it's closest to bot, it'll tell me bot. If it's mid, then it's mid, and if it's top, it's top. And this hopefully will solve your inting jungler's terrible vision. So send them this during the pregame, and they won't be terrible as usual. Okay, there we go. That's it. That's it, man. That's it.
Nice.
That's it.
Welcome. This is going to be the code portion of my video. So what we're doing here is we're importing the exact same libraries as before, and the next line we ask the user what champion they want us to track. We just save that into our variable called selected champion. Now these functions that I wrote, this one's the same as all my other projects, but these three I will explain. Let's start off with draw rectangle though. So with draw rectangle, we actually have to first look at these lines of code. So first, what we're doing here is we're making a new window called live with OpenCV, and then we're going to set our mouse callback to that window and our function. Essentially what the set mouse callback does is it senses when there's a mouse input, such as clicking or whatever, but it tells the laptop or the computer basically that something's happening with the mouse. All right, send that to the function and let that function do whatever it needs to do on this window. Now, resize window is exactly as it says. I just put it in the resolution of 1920 by 1080 because I assume most people have that. All right, moving on. We should now discuss the draw rectangle function. So it takes an event, an x, y, flags, and param. What event does is it's the event that we're sending it. So whether it's a mouse or whatever that's happening, we're sending that as the event. Now x and y is just the coordinates of your current mouse position on your screen. And to be totally honest, I don't really understand what flags and param is. I'd have to look into the documentation. So first we set it as global variables because we want to edit and use these variables from 4 here. Now let's get into what these if statements are. So the first if statement is simply to check if the event that we're getting is a mouse click. And to do this, we set if the event that we're given is equal to an event where the left mouse button has been pressed down, then we want to check all of these three things that could have happened. So let's look at the first one. The first one states that if the top left and the bottom right has been clicked and they're all set to true, then we want to basically reset everything. Okay, well, let's make a hypothetical situation. Let's say I clicked once. So it's going to go through. Okay, I clicked. Yes, that is correct. Are both of these set to true? No, because down here they're still set to false. All right, then is top left equal to false? Yeah, because we still have it as false. Then let's go into here. What we're doing here now is we're going to set point 1 equal to the exact coordinate where my mouse was when I clicked. And then I'm going to set top left clicked equal to true. And now let's say, and again, hypothetical situation, I clicked again. Now I've clicked 2 times. So I'm going to go here. All right, I clicked. Cool. Is top left clicked? True. Yes, it is. Is bot right clicked? True. No, it's not. It's still false. Okay, so we don't go into this one. Is top left click equal false? No, it's true. Okay, so we have to go here now. Is bot right clicked equal to false? Yes, it is, because we haven't changed this value. Since it is, we again save the exact location where we clicked on the screen on our variable point 2. And we also set bot right clicked equal to true. So now we know the top left corner and the bottom right corner where we clicked. This will be really useful later for drawing a rectangle, and I'll explain a bit more later. Now let's say hypothetically we clicked everything twice and now the user clicks again. So if we click again, it's recognized by this if statement, and then it's going down here and it's okay, checking. Is top left clicked equal to true? Yes. Is bot right clicked equal to true? Yes. Okay, then let's reset everything and we restart, because we don't want more than 2 points on our screen. Now we've explained all of this, we can go down to our model. What we're going to do is we're going to run a while true loop, so that it keeps running forever. And we're going to take screenshots of our entire screen, just our home screen, right? What we're going to do is change that into an NumPy array and then correct the color format from BGR to RGB. This is because OpenCV only allows NumPy arrays in the form of RGB. That's how it works. Now let's go into these 2 if statements, and one is obviously easier than the other. Let's start with this one. This if statement just simply checks if top left has been clicked. So remember up here, if top left equals to clicked, yeah, okay, we set it equal to true, right? So let's say it is true right now. Then we want to draw a circle where we put point 1. And if you remember, point 1 is the exact position that our mouse was when we clicked. So we can draw a circle right there. Easy enough. In our second if statement, it gets a bit more complicated. So now we're checking if both the top left has been clicked and the bottom right has been clicked. Okay, so if both of these have been clicked, what do we want to do? We want to draw a rectangle on our frame from the top left corner to the bottom right corner. And these are 2 points that we've saved from above, because remember, if bot right is also clicked, we save that position as well, so we can use it. We see that we set it to red, and we also give it a thickness of 2. And that's that. We just have drawn a normal rectangle. Now, sorry, I just did a quick change. I actually flipped these 2 variables around if you go backwards a bit into the video, but I fixed them now and they should make more sense. So if we have both of these points, what can we do with them? Well, we can split them into their x and y component, right? So if we do that for both points, then we can figure out what region of our screen do we actually want to use our model on. Well, that's what model region or map region is. Here, we again use PyAutoGUI to screenshot a region of our screen. Now, what I'm going to show you is the official documentation for PyAutoGUI screenshot. All right, here we go. We see here that we can pass in a keyword argument called region. This essentially lets us pick where we want our screenshot to be taken. Here in this example, he chose at 0, 0, 300, and 400. And those values, respectively, mean left, top, width, and height. All right, let's move back to our example and see how that fits into ours. All right, here we are. All we did here is we did a bit of logic. All right, so our top left corner is simply just whatever 0.1 is. That's already established. But what about the width and the height? Because we can't just give our bottom right corner, we actually have to calculate the width and the height. Well, if you think about it, the width would actually just be x2 minus x1. Let me make a quick example as to why that is. So wouldn't you agree here that if we wanted to find this width, we'd subtract this longer section by this? So if we did that, code-wise, we would actually find the width. And that's what we're doing here. This is our bottom right corner's x-coordinate, which would be farther than our bottom or top left corner. So that's why we subtract it. And the same logic applies to the height. So now we know where our map is, thanks to where the user labeled on the screen. Now, you have to remember again, we have to change the map region into what OpenCV accepts, which is a NumPy array in the color format of RGB. Okay, perfect. All right, now let's try and explain what this line of code does. Let's first look at what champ actually does, and we see that it takes in our selected champion from the very start. All right, so what's going on? We give it the names Graves, and what's going on is we're looking at the names variable, which is just an array of all the champions that are in the data set I used. And what I'm doing here is I'm simply finding the index where Graves is. And why is this so important? Well, later on, when we use our actual model, we want to specifically only look for Graves. And how do we do that? We pass in the argument classes equals to champion int. And champion int is just the number or the index where Graves is located in this huge array. And the reason behind this is now YOLO can understand that, okay, I'm simply looking for this class at this index. So it knows it has to be Graves. If I didn't have this and I didn't have this, it would just predict every single champion visible on the screen. And I obviously don't want that. I only want to track the jungler. Okay, so now that we have that and we have predicted the model, what does closest lane do? All right, so in which lane, we see that it takes in a source, which is essentially our image, label file path, which is, as it says, just the file path towards the label. What we do first is we're going to check if it's empty by using os.path.getSize. This essentially gets the size of whatever file path we give it. All right, and if it has no, detected value, then we're going to return no detection because we simply don't detect anything. All right, in our next line, we're just going to read our text file. We're going to split it using readlines.split to get just the champion info. And from there, we can unpack it using indexes. These essentially give us the coordinates of our champion, specifically the center. And if you remember from my box detection video, we actually get random float values that are very much like ratios that we will have to use later to get the exact position or coordinate of our champion. That's what we did here. We're taking a ratio, multiplying by the width to find the exact spot that our champion is on the x-axis. And we do that on the y-axis too. And simply, that just gives us the coordinate. And that's exactly why I have champion position equal to that. Now, what are these random 3 lines of code? Well, not 3, but you know what I mean. What are these 3 variables doing? Setting the dots that you see on my mini-map. Now, you might be wondering, Austin, aren't these just kind of random? Well, Or kind of. What I did was I first found the mid lane's chords. So obviously the mid lane should have a coordinate at half the width and half the height of my map. Okay, what I did from there is I simply just added a 100 or subtracted 50 or added 50, and I just kept doing that to find the right spots that I needed. And this forms a diagonal line. Okay, easy enough. We have the mid lane chords. What about the top lane and bot lane? They look like almost like a L or a corner. Well, I went off from the mid lane chord and I simply just played around a bit, and these values just worked for me. These values gave me exactly what I wanted, where I wanted to put it, so I just kept them. Now, you might be wondering, okay, well, these are just an array of integers. They don't really give us a circle, don't? No? That's true. But later, I'll show you how I actually draw a circle on our map. Now, let's move on to this section of the code. So ignore these two lines for now, and let's just move on to these for loops. We're going to loop through all of these coordinates on top lane chords. So, for example, the first iteration would be that. Okay, so that's what t would equal. What do? We draw a circle around that coordinate that we just pass in. And that's why and how we draw circles on the map. Now, what else do we do? We're going to check the champion's distance from that said circle. As you might remember from math, either 20 or 30, we learn about the distance formula. And this is really useful because this is how we find the distance between two coordinates on a plane, usually. We're doing the same thing in our code. Okay, so we're going to translate this to our code. That's exactly what this is actually. So we're taking square root of the absolute value, I just added that because I wanted to avoid errors, of just two coordinates subtracted from each other, squared. It's as simple as that, and then added together. Now, you can see here, what is champion position 0? Well, if you remember from here, it's just the x coordinate of my champion. This is where my champion's located, so this would just be the x coordinate of my champion. And remember what t is? T is just one of these coordinates. And what's t0? Well, it's actually just, again, the x coordinate where my t is, or sorry, where my circle is. So what I'm doing here is taking the coordinate of my champion and the circle, except this is the y axis, and I'm finding distance. It's that easy. Now what I do next is I check if that distance is actually less than our top distance. And this is where we want to go back to this line. Why would I set all of these values to 1000? I actually have a reason. Let's say this is a lot smaller. That would obviously mean it would never be less than top distance. But I want it to be less, right? I'm trying to find the shortest distance of my champion to a set circle. That way I know, okay, if he's closer to a circle that's in mid lane, then I can display mid lane. That's essentially the whole logic behind this. So I made it a really large number in order to always have something, like at least a shorter distance than 1000. So let's say it is smaller. Then we take the top distance and we set it equal to the champion's distance from the circle. Now, if we do this for all of top lane chords, we should have the shortest distance our champion is to a point in our top lane. And now we do this for mid lane and bot lane, and therefore bot distance will also end up as the shortest distance to a bot lane circle. Now, after doing that for top, mid, and bot, we add that to all distance. And the order actually matters. And here's the reason. In our if statement, what we do first is simply just check, okay, if nothing happened, then he's obviously not on the screen, and we return fog. And I know nothing's happened by indexing each value and checking if it's 1,000. If it's 1,000, that means that our original value that we set it equal to had no effect, and nothing happened in these lines, so therefore it just got through, and we should just return fog because nothing happened. But else, we do this. We find the closest lane by looking at our array and indexing to find where the minimum value is in our array. Why is this important? Well, remember how I said I essentially added the shortest distance that our champion is to a top, mid, and bot circle? Well, if you obviously find the shortest distance out of all of these, you should find the respective lane that he's in. So if I use min, I get that. And then I want to use index to find where it is and why. Why do I care about the index so much? Because I'm adding top first, and then mid, and then bot. So let's say closest lane return me 1. I know I added the mid lane distance second, meaning its index would be 1. Therefore, I can know exactly where my champion is just off of that, because I added the mid distance at index 1. Okay, let's say it returns me 2. Well, I added bot distance at index 2. So therefore I know it's bot. And the same thing for top lane. And therefore we know exactly where our champion is now, and it's very simple. And that basically explains which lane. Now after that, it actually comes the easiest part. We finished all the calculations, and now we just have to put that piece of text on our map display or window. So what we're going to do is we're going to set the text equal to what we got from closest lane. And closest lane is calling which lane. And which lane, we know, returns us a string of either top, mid, bot, or fog. So let's say it returned top. What's happening here is we're just passing that in. We're just going to return and display top as our text. Next, org simply just is where our text will appear or start. Now what I'm doing here is simply just picking a font, and next I'm telling the size of my text, and then the color, which is white, and our thickness, which is going to be 2. Now all I'm going to do is open a window called map and display the image map that I've altered throughout this program. Next, I'm also going to show the live window with each frame. And then finally, what I do here is I wait and check if escape key is pressed. And if it is, I want to delete the directory of this file path. And then I'm going to break, meaning I've escaped this while true loop. If I break it, then I go out and I want to just destroy all the windows that have popped up. And it really is just that simple. That's it to the coding portion of my project.
So essentially, right, remember where I said like, okay, I'm going to draw the boxes on the map, right? And now this window popped up, right?
Mm-hmm.
Do you see those dots? That's basically
Yeah.
what's the like landmarks for bot
Yeah,
lane and
nice.
top and mid. So if you want to do it yourself and try, you can try walking to mid right now. Yeah, so right now I still have vision. So you were last seen bot. I know that. And then if you do appear in vision, like around here at mid, I still don't see you if you're there. Okay, yeah, instantly changes to mid. Do you see that?
Oh damn. Oh my gosh.
So
let me go
if
top,
you do
let me
the
go top.
yeah, if you go do the same at top, should also work. Yeah, go to the wave because yeah, there, perfect. Top.
Oh man. Wait. So if I go in the jungle, will it say top jungle or will it say top?
It'll just keep saying top. Go from top to bot. You can also try that.
Alright, sick.
It's
Let's
up to
run
you.
back then.
Okay, are you traveling from top to bot right now?
Oh shoot. Yeah. I got.
Yeah,
I
don't
got
get
touched.
into vision. Nice.
How long does it take you, bro?
I think a week, but most of it was on finding pictures and stuff.
Makes sense.
Yeah, there, your bot.
Nice. Wait, that's
Yeah.
actually insane.
What I'm doing with each second or each frame is essentially I'm detecting you, right? I take that coordinate and I take the coordinate of all the points on the map. Like, I think you see like
Yeah.
the green, red, and blue.
Yeah,
Right.
the green. And you're saying which one's closer?
What I'm doing is actually like, you know the distance formula in math?
Yeah.
Yeah, I thought I was so smart. I used that to calculate the distance of you to every single point.
Mm.
And I took the lowest one, and obviously with the lowest one, I know where you're at. But yeah,
Alright.
that's the whole project. I think we're good.
Alright, let's join back.
Yeah, I just want to say, man, thanks for taking that little short time to help me, man. Damn, he left. That's crazy. Wow.